Hello everyone, and welcome to the third part of this MOOC dedicated to hydrocracking. In the first two parts, we spoke about the location of the hydrocracker in the overall refining scheme, and we detailed the composition of the feed. So let's now focus on the hydrocracking process. The hydrocracking process involves hydrogen and a catalyst. To let the cracking reactions take place, we need the simultaneous presence of hydrogen, pressure, temperature, and a cracking catalyst. But this cracking catalyst does not tolerate metals, asphaltenes, or nitrogen. So we need a pre-treatment section to remove all these poisons. And the chemical reactions involved in this pre-treatment section require operating conditions that are quite similar to that of cracking. We will therefore logically have a sequence of two catalytic sections. A pre-treatment section on the catalyst specially designed for this purpose that will work typically at 150 bars and between 370 to 400 degrees C. Then a cracking section will follow with a cracking catalyst that will work under the same operating conditions, I mean temperature and pressure. So I suggest logically to start the description of the process. The typical VGO produced in vacuum distillation is stored in a tank at a temperature of around 70 degrees C. Indeed, a VGO tends to become solid when its temperature drops below 50 degrees C. So, to prevent it from solidifying, we keep the storage tank temperature close to 70 degrees C. Oh, I hear in the headset that some of you find it hard to believe that the VGO solidifies at ambient temperature. In this case, I propose a duplex live from the Refining is Exciting laboratories. Hello everyone! I just received a VGO sample and see how it is almost solid at ambient temperature. That's it for me. I leave you now for the rest of the MOOC dedicated to the hydrocracking process. Bye-bye! Thank you very much, and now let's go back to the process description. The VGO pressure is then increased with a feed pump to a pressure of about 10 bars. Then the VGO temperature is increased up to 200 degrees C. As we have already done in the MOOC dedicated to FCC, let's do a heat balance. As for the FCC, we will focus on a hydrocracking unit treating 150 tons per hour of VGO feed. Between 70 and 200 degrees C, the heat capacity of the VGO is about 0.55 kcal per kilojoule per degree C. To increase 150 tons per hour of VGO from 70 to 200 degrees C, it requires about 150,000 multiplied by 0.55 multiplied by the temperature difference, which means 10.7 gigacalories per hour. We will detail the origin of these calories later in this MOOC. Once the VGO temperature has been increased, we increase its pressure with a pump. We increase the pressure to a level allowing the cracking reactions to take place. We typically need a pressure of about 170 bars. Once the pressure has been increased, hydrogen is injected. This hydrogen is usually produced in a dedicated unit to cope with the hydrogen required by the hydrocracking process. The hydrogen purity, which is called the makeup hydrogen, is about 99.5 to 99.9 volume percent purity. This hydrogen feeds the hydrocracking unit at a temperature of about 100 degrees C, since it has been compressed to meet the pressure of 170 bars. But by the way, how much hydrogen do we need to inject? We'll see that in the next part dedicated to the hydrocracking process. While waiting for the fourth video, do not hesitate to answer the 5 questions of the quiz. See you very soon for the next part. Bye-bye!